WebAssign 8, question 1. For this WebAssign, please note the note at the top. It says, note from Mr. Gaffey. In this assignment, write the coefficient in the first box followed by the formula in the second box. If the formatting becomes an issue, you may write out your answers on paper and bring them to class. Refer to solubility rules. So this is one of those few assignments where the formatting may get in the way of getting those green check marks from the WebAssign site. So as you follow along, note I'll point out some of the formatting things that WebAssign is looking for. But once again, if the formatting gets in the way, just write out your answers on paper and bring it into class. The other thing I would have you note, under where it says question details, if there's no reaction, write no reaction. And then formatting wise, if there's no reaction, type NR into all of the answer boxes for that reaction. Okay, and that'll come up in this example. Let's look at part A. I have compounds which may differ from yours, but you would follow the same steps and the same solubility rules. So let's begin. In part A, in my case, I'm asked to write the balanced molecular, complete ionic, and net ionic equations when lead 2 nitrate reacts with potassium chloride. So we'll start with the balanced molecular equation. To write the products for this reaction, we're simply going to write the novel combinations of ions. As with any ionic compound, the positive ion is always listed first, and the negative ion is listed second. So in lead 2 nitrate, the lead ion is first, is the positive ion, and the nitrate ion is the negative ion. And if we look at potassium chloride, potassium is positive, chloride is negative. So what are the new ways that we can combine those ions? Well, it's always got to be positive ion paired up with negative ion. So we could put potassium with nitrate. Potassium, if you look on the periodic table, is in group 1, so that's a +1 charge. Nitrate, of course, is a -1 ion, which you know from your polyatomic ions. And the other product would be lead 2 ion paired with chloride ion. Let's think of our solubility rules. When we're mixing any two ions, any two compounds as reactants, automatically they are aqueous. There's also an aqueous behind each of those compounds in part A as they're listed. The interesting part is going to be when we get to the products. So if we look at potassium nitrate, by rule 1 of the solubility rules, I would say, okay, that salt contains the nitrate ion and is therefore aqueous. There's another rule that would apply here, although it's not as important as rule 1, as rules higher in the list trump rules lower in the list. And that is rule 2. Group 1 metal salts are also aqueous. So rules 1 and 2 would both reinforce each other to make potassium nitrate aqueous. In the case of lead 2 chloride, if you look at rule 3 of the solubility rules, chloride salts are aqueous with some exceptions, and one of those exceptions is when it's paired with lead 2 ion. So here we have a solid. So we do precipitate something in this reaction. When writing the balanced molecular equation, we actually have to balance it. So we'll need to balance out the chlorides. We'll need a coefficient 2 in front of KCl, and we'll also therefore need a coefficient 2 in front of KNO3. There's the balanced molecular equation. Now let's move on to the complete ionic equation. Substances which are both strong electrolytes and aqueous, and both of those conditions need to be met, will be written as broken apart in the complete ionic and net ionic equations. In this equation, every compound listed is an ionic compound, which automatically makes it a strong electrolyte. So that characteristic is checked off for all 4 of the compounds that appear in this equation. What may or may not be checked off is whether they're aqueous. In the case of lead 2 nitrate, we have an aqueous species, potassium chloride, aqueous, potassium nitrate, aqueous, lead 2 chloride, solid. So we're going to keep the lead 2 chloride together intact. Everything else is going to get broken apart. Let's begin. This part actually isn't that hard. It's just tedious. It's a little bit long. The subscript 2 behind the nitrate gets carried as a coefficient in the complete ionic equation. And this equation, the complete ionic equation, is going to be the longest always. So those are the reactants. Below it, I'm going to write the products because I'd run out of room otherwise. The solid lead chloride cannot be broken apart. Notice that I'm neglecting to write states of matter for anything except for solids because it just gets tedious. If I put AQ behind everything, it would take me all day. Okay, to write the net ionic equation from the complete ionic equation, we can cross out anything that appears both on the reactant side and the product side of the equation. In order to do that, it has to be an exact match in terms of the compound listed, or the species listed, along with its charge. It has to be an exact match. So 2K plus does appear exactly as listed on both sides of the equation. 2NO3 minus also appears exactly as listed on both sides of the equation. What do we have left? Lead 2 ion, 2 chloride ions, and the intact salt, lead 2 chloride. When typing this in to the WebAssign, remember they're asking you to type in the first box the coefficient and in the second box the formula. So make sure that you're going in that order: small box coefficient, next box the formula. And then there's another caveat in terms of formatting. They want a coefficient 1 if it's a coefficient 1. So you know how when you write chemical equations you don't need to write a 1? Well, when formatting with WebAssign you do. So for instance, if we go back to part A here, in the net ionic equation, I want to write 1 Pb2 plus and 2 Cl minus. And you have to actually write out the 1 PbCl2 and so forth. That completes part A. We'll do a separate video for part B.